Good morning. I hope you all are having a great day and that you're settling into our online digital learning. I really can't wait to get back into the classroom. I really miss all of you and hope that will happen soon for all of us. So we're continuing on our unit with systems of equations. So far we've learned two methods. The first method was graphing. The second method was substitution. And today we're going to learn the final method, which is elimination. There's a lot of steps here, as you can see, so I'm going to read those out, but again, once we start practicing, it's going to make a whole lot more sense. The first step says you must have the same or opposite coefficients for one of the terms in the systems of equations. It may require you to multiply one of the equations by a factor that will give you the same or opposite coefficient. The second step says add or subtract the equations to eliminate one variable. As it's called elimination. That's your goal. You're going to eliminate one of the variables so you can solve a one-step equation. Step 3 says solve the resulting equation for the other variable. Then you'll use substitution to put it into either of the equations to find the value of the first variable. You can always check your solution by putting the ordered pair back into both equations. So let's do some practice. Okay, here's the first one. A minus 3b equals -1, not 1, -1. 2a plus 3b equals 16. Okay, so the first thing I look at is my variables. In the first linear equation, I have a minus 3b equals -1. In the second linear equation, I have 2a plus 3b equals 16. So I notice in my a's that I don't have the same coefficient. The coefficients are the numbers in front or opposite signs. But if I look at my b, I have -3 in the first equation and +3 in the second. So I'm going to be able to eliminate that. So I have to decide, will I add or subtract to eliminate that? So if I have a negative and a positive, I'm going to add those, because when you add a negative and a positive, it becomes 0. Those go away. So now I have 1a plus 2a, that's 3a, equals -1 plus 16, which is +15. I divide by 3. And I get a equals 5. So now I have part of my solution. I have a. You can choose to put a into either equation. It really does not matter. I'm going to stick it in, I'm going to stick it into the second equation. So I'm coming up here and I'm going to put it in. So I'm going to have 2 instead of a, 5. So 2 times 5 plus 3b equals 16. When I multiply, I get 10 plus 3b equals 16. I'm going to subtract 10 and divide by 3. And when I do that, I get b equals 2. So my solution is the ordered pair 5, 2. And I should be able to put that back into either equation, and it should be true when I do that. Okay, so far so good. Let's go to the next one. The next one we're going to do has decimals. 2 58/100 d minus 300 e equals 15. Then you have 1 72/100 d plus 300 e equals 19 4/10. So again, to use elimination, I'm trying to get rid of one of the variables. If I look at the coefficients in front of my e, I see I have opposite operations and the same coefficient. Again, I can add these. When I add these, I eliminate e, and I'm left with 4 30/100 d equals 34 4/10. Okay, since I don't have a calculator in front of me, I'm just going to multiply this through by 10, and I get 43. It's going to move one place over. D equals 344. Divide by 43, and I know that 43 goes in evenly 8 times to 344. So now I'm going to plug it back in. I'm choosing the second equation again. You can choose whichever one you want. So I'm going to have 1 in 7200ths times 8, because I'm replacing D with 8, plus 300ths E equals 19 and 4/10. When I multiply that, I get 13 and 7600ths plus 300ths E equals 19 and 4/10. When I subtract 13 and 7600ths from both sides, I get 300ths E equals 5 and 6400ths. I can clear this by multiplying by 100 and getting 3E equals 564. And 3 also goes into 564 evenly. It goes in 188 times. We write our solution alphabetically, so D is 8 and E is 188. You could plug that in and check, and that should work. All right, hopefully so far so good. So let's look at some that are a little bit different because they don't have the same coefficient or opposite signs to start. So if I have m plus 2n equals 6 and negative 2m plus 4n equals 28, I look at my m's. I do not have the same coefficient, but I do have opposite signs. In my n's, I do not have the same coefficient, nor do I have opposite signs. So for me, I'm going to eliminate m. And how do I do that? I have to get the same coefficient. So if I have 1m and I want to have 2 m's, I'm going to multiply through by 2. I am multiplying everything by 2, every term. The m, the 2n, and the 6. I'm going to rewrite it down here. So I get 2 times m is 2m. 2 times 2n is 4n. 2 times 6 is 12. Okay, now, if I look at my m's, I have the same coefficient and opposite signs for my m's. What's going to happen when I add those? They eliminate. 4 plus 4 is 8n. 28 plus 12 is 40. So I divide by 8, and I get n equals 5. I take that 5. It does not matter where I plug it in. I'm going to go ahead and plug it into the first one. M stays m, but I get 2 times 5 equals 6. So I get m plus 10 equals 6. Subtract 10. M equals negative 4. So my solution, alphabetically, m comes before n, is negative 4, 5. I should plug that in and it should give me the same thing. All right, I'm going to try to squeeze in one more before I go to the next line. Let's see. Number 4. 2s plus 3t equals 35. 5s minus 4t equals 7. Again, looking at my s's, I do not have the same signs. Or I'm sorry, I do have the same signs, but I would like opposite signs so I can just add them. I don't have that, nor do I have the same coefficients. If I look at my t's, I have opposite signs, but I don't have the same coefficients. I am going to eliminate my t's, but I'm going to have to get it so that my coefficients are the same. And the first factor where they become the same, or first multiple, I should say, is when we get to 12. So what times 3 gives me 12? It's 4. So I'm going to multiply through the whole thing by 4. What times 4 gives me 12? It's 3. So I have to do something to both linear equations this time. Okay, I'm going to start and rewrite the top one first. 4 times 2 is 8s. 4 times 3 is 12t. And 4 times 35 is 140. Now I'm going to do the second equation below that. And I'm going to get 5 times 3 is 15s. 3 times negative 4 is negative 12t, and 3 times 7 is 21. often what gets forgotten when you're eliminating is that you have to multiply that factor by every single term. And a lot of times that gets forgotten. I'm ready to add now. 8 plus 15 is 23s. My 12s go away because 12 plus negative 12 is 0. They eliminate. And that equals 161. I'm going to divide by 23. I'm going to divide by 23. This does go in evenly. 23 times 7 gives us 161. So I have my S value. Again, it doesn't matter where you plug it in. I'll go into the first one. 2 times S, or 2 times 7, plus 3t equals 35. 14 plus 3t equals 35. You know, I'm to the point where if you can do some of this mentally, like subtracting your 14 and dividing by 3, I'm okay with you doing it. For example, you don't have to show the subtracting of 14. You can get to doing it mentally and get 3t equals 21. And then if you're comfortable dividing by 3, you can show me that t equals 7. So S comes before t, but both solutions are 7. So the ordered pair is 7, 7. Okay. All right. Let's try, I want to do another one with you. Let's see. Let me go over here. So this is going to have a system of equations that have 3 linear equations. So it's going to take a little bit of room here, but I think we have plenty left. So let's see. It's not number 8. It's number 5. Okay, number 5, we have x plus y plus z equals 7. I'm going to put a line through my z so it doesn't get confused for 2. 2x minus y plus z equals 4. 3x plus 2y plus 7 equals 11. Okay. The first thing you want to do is eliminate one variable from the first 2 equations. So to do that, I'm going to go ahead and take my first 2 equations and rewrite them. And I am going to eliminate z. You can eliminate y if you want. I'm just choosing z. So when I do that, I'm going to subtract because they're both positive. So this is a little different when you're subtracting. Okay, so when I do that, I'm going to have 1x minus 2x gives me a negative x. Y minus y. What does that give me? It gives me positive 2y because a negative y minus a negative y becomes y plus y. Z minus z is gone, and 7 minus 4 equals 3. So that's the first one. Now I'm going to take the second 2, but I have to eliminate z again because I chose z. I can't eliminate a different variable. I have to eliminate z again, and I have to subtract again to do that. So I'm subtracting to everything. 2 minus 3 is negative 1x. Negative y minus 2y is, negative y minus 2y is negative 3y. The z's go away, equals negative 7. So it's really important that you're able to keep up with your operations and your signs. Now I'm going to take these 2 equations right here, and I'm going to eliminate from there. I'm going to eliminate x. So to eliminate x, I have this same sign and I have the same coefficient. I'm going to subtract again. Negative 1 minus a negative 1 means negative 1 plus 1. That's gone. 2 minus a negative 3y is a 5y. Equals 3 minus negative 7, which is 3 plus 7, or 10. So now we know that y equals 2. I'm going to take that y equals 2 and plug it into one of these. It does not matter. I'm going to run out of time here, so I'm going to have to stop this and start right back up here. So in a new video. I'll be back in a minute.